All right, so I wanted to just do a video for problem number 3 for my worksheet rather than spend any time in class on it tomorrow. But the idea is that we have two vectors, t1, which is this vector here, and t2 over here. And these are being pulled down by a weight, which is 100 pounds. Okay, and so we want to know, basically we're asked to describe what are these vectors. So find their magnitude and find what the actual vectors are in terms of their horizontal and vertical components. So the first thing that we're going to do is try and figure out how do we write t1 and t2 as a vector. And so we're going to write t1 as the vector, and we're going to think about what's the x component and y component. So what I'm thinking of here is I'm thinking of kind of adding, I'm not going to draw it, but I'm going to think about adding an axis here and here, and we want to know kind of what are the x and y components of this first vector t1. And so to do that, what we'll do is we'll take cosine of this angle here, so cosine of the angle that t1 makes with the x-axis, so that'll be cosine of 130 degrees times its magnitude. We don't know its magnitude just yet. That's cosine of 130 degrees. And then, so that's the x component, and then the y component would be the magnitude of that vector times sine of 130. So sine of 130 degrees. And that works out to be roughly, so we'll take the magnitude. This magnitude is a constant. We can actually factor it out in a second, so I'll show you what that looks like. But this will be some number. I could plug it in and give exact formulas, but this is actually fine. So this will be what the vector t1 is, and then t2 will be similar, except the angle that it makes is going to be slightly different. So this will be the magnitude of t2 times the cosine of 32 degrees times the magnitude of t2 times sine of 32 degrees. Okay, so those are our two vectors. We know that if we add these two vectors together, that's going to equal the force that's being pulled down on the sum of those vectors. So we know that t1 plus t2 is going to be exactly the same as our vector w. Okay, so they're going to add up to 0, or t1 plus t2 is negative w is maybe another way to say it. And so this means that what we're going to do is we're going to take t1 plus t2 and set that equal to 0, 100. That's the vector, because there's no weight that's being applied in the x direction. It's all in the y direction. And so that's the vector. And so we want to solve t1 plus t2 equals this vector. And so t1 plus t2 you can just solve, you can just add that up. This is going to give you the magnitude of t1 times cosine of 130 degrees plus the magnitude of t2 times cosine of 32 degrees. That's the x component of the sum of the vectors, and then the y components will be the magnitude of t1 times sine of 130 plus the magnitude of t2 times sine of 32. And we know that that should be equal to, so setting these equal implies that this should be equal to 0, 100. And now what this means is that we have two equations and two unknowns. So we're still looking for the magnitude of t1 and t2. We don't know those exactly. But what we have is a system of equations. So we know that the magnitude of t1 times the cosine of 130 plus the magnitude of t2 times the cosine of 32 degrees is going to equal, so we're setting these two vectors equal to each other. The only way that vectors are equal is if all their components are equal. So we know that the first component should be 0, and the second component, which is the magnitude of t1 times sine of 130 plus the magnitude of t2 times sine of 32, we know that that should be equal to 100. And then what we're going to do is we're going to have two equations with two unknowns. So we're going to solve for the magnitude of T1 and T2, and this is kind of a messy system of equations, but it turns out that when you do this, what we end up with is the magnitude of T1 works out to about 85.64. Okay, so it'd be pounds. And the magnitude of T2 is going to work out to be 64.91 pounds. Okay, that comes just from solving this system. You could think of basically this is A, this is B, A and B, and then this is a linear algebra problem, or just a system of two equations. What makes these numbers kind of messy is that cosine of these angles don't come out very nicely, so that's what it is. And so once we have the magnitudes, we can go back and we can plug in. Remember that we wrote T1 and T2 in terms of their magnitudes, and so you can plug everything in there. And so if you plug in the magnitude for T1, you plug in cosine and sine of 130 degrees, that'll give you T1. So it turns out that the vector T1 is going to have components negative 55.05, comma 65.6, and T2 will have components 55.05, comma 34.4. So those are the two components there. So that's what we were looking for number 3. This problem is a little bit too difficult, I think, for an exam, but I think it's just a good kind of way to talk about some things about vectors, particularly if we want to solve equations for vectors. That means that we generally will have a system because we have two components. So you'll want this first component to be equal to 0, the second component equal to 100, and so on. So that's the problem.